Hello everyone, welcome to Sangam Tutorials, SP Gubi online classes for Ncert, 10th standard and Cbse, 10th standard for mathematics and science. In today's session, we will be going with very important riders on Pythagoras theorem, including converse of Pythagoras theorem. Very important, you have to practice them. It needs practice because once you see it, you may feel that you have understood, but when the situation arises where you will have to recall that at a particular situation, you may fail in that. So please practice the problems. I hope you are enjoying the sessions. We are nearby the 100th videos. So in a very short time we are going to cover 100 videos. So with this, today we will enter into the problems, that is very simple application and riders on right angle triangle, that is Pythagoras theorem. A guy wire attached to a vertical pole of height 18 meters is 24 meters long. Okay, so there are two things here. One is the guy wire. Guy wire, maybe you have seen for the electric poles, they have pulled a metallic wire and it is tied to the ground. That's called the guy wire. So a guy wire attached to a vertical pole of height 18 meters is 24 meters long. So here guy wire is 24 meters and vertical pole height is 18 meters. So this is how we have to go with that. So very simple. A guy wire attached to a vertical pole of height 18 meters. So height of the pole is 18 meters and the length of the guy wire is 24 meters. So that is how we have to understand here. Be very careful in that. And a stake attached to the other end. Stake in the sense you will be having a metallic rod or a wooden thing. Maybe in this case maybe he has taken a metallic straight rod like thing where it is pointed at one end so that it can be easily inserted into the ground, so that you can keep it on the ground and when hit with the hammer it goes into the ground. So that's called a stake attached to the stake. So that is attached to the other end of the guy wire. So for the guy wire, one end is attached to the vertical pole and the other end of the guy wire is attached to the stake. Okay. How far from the base of the pole should the stake be driven, that is driven into the ground, so that the wire will taut. Taut in the sense it doesn't, in the sense it doesn't, it will be very straight, it will be like a straight line. It doesn't have any, that is maybe it doesn't look loose like thing. So it is very tight. It's in the form of a straight line. It doesn't have any taut like this. That is bending like this, right? Okay. So a guy wire attached to a vertical pole. So this is the vertical pole we will take. So vertical pole will be perpendicular to the ground always. A guy wire attached to a vertical pole of height 18 meters. So vertical pole height is 18 meters and the guy wire is 24 meters. So one end of the guy wire is attached to the that is the vertical pole and the another end is attached to the stake. So stake is here somewhere here. So this part of the stake will be inside the ground. So this is driven inside the ground. Okay, stake is driven inside the ground. A part of it is driven inside the ground. So stake attached to the other end. How far from the base of the pole? How far from the base of the pole should the stake be driven, so that driven inside the ground, so that the wire will taut? In the sense the wire should be like this. It should be in a, it should look like a straight line. It should not be loosened like this, right? So this is, take it as AB. Let AB be the vertical pole and let C be the point where the stake is driven into the ground. Okay. So let AC be the guy wire. So now, so the length of the guy wire is 24 meters. Very simple. So you have to find this distance. At what distance from the base of the pole should be the stake driven inside the ground? So this length we have to find out. Very simple, right? So in triangle ABC, angle B is equal to 90 degrees. So by applying Pythagoras theorem, AC square is equal to AB square plus BC square So here AC square is 24 square. 24 square is equal to AB square is 18 square plus BC square remains unknown, so that the BC square will maintain in the same manner. So 24 square is 576 is equal to 18 square is 324 plus BC square. So BC square is equal to 576 plus 324. When they are transposed to the RH, that is LHS, it becomes minus 324. So BC square is equal to, so it is 2, 5 and 2, okay, it is 252. BC square is 252. So when we take square root on both sides, that is square root of BC square is equal to square root of 252. Square and root cancels. So BC is equal to, we have to take the square root of 252 here. So square root of 252 will go like this. So it is 2. Let us go with like this. So 2 1s are 2, 2 2s are 4, 2 6 are 12, again 2 6 are 12, 2 3s are 6, again we go with 3, 3 2s are 6, 3 1s are 3, so it is again 3 7s are 21 and 7 1s are, okay. So 2 2s are 4, 4 3s are 12, 12 3s are 36. So we can take 36 into 7. Because why I took 36 into 7? Because 36 is a perfect square there. So for 252 we can write it as 36 into 7. So BC is equal to, when you take 36 outside square root, it becomes the square root of 36, that is 6 root 7 meters. So the length of BC is 6 root 7 meters. So the stake should be driven at a distance of 6 root 7 meters from the base of the pole. So this distance what we have got is here 6 root 7. So we have to mention this in the form of a statement. Therefore the stake should be driven at a distance of 6 root 7 meters from the pole, right, or from the base of the pole, right. So it's an important problem for 2 marks. Okay, we'll go to the second problem. So very important. An aeroplane leaves an airport and flies due north at a speed of 1000 km per hour. Just imagine an airport and an aeroplane moving towards north at a speed of 1000 km per hour. At the same time, another aeroplane leaves the same airport and flies due west, that is towards west. Another aeroplane it flies towards west at a speed of 1200 km per hour. You can see the difference in the speed. So how far apart will be the two planes after 1.5 hours? So one aeroplane goes towards north at a speed of 1000 km per hour. At the same time, another aeroplane leaves the same airport and flies at a speed of 1200 km per hour at the same speed. So two aeroplanes are moving in this direction. One is in this direction towards north, another is in this direction. So both the aeroplanes are moving in this direction. So after traveling 1.5 hours, what will be the distance? How much distance they are apart? So that is, we have to calculate this distance. This distance we have to calculate. Okay. So here speed is given, distance is not given, but time is given. So using distance, that is speed and time, we can easily find out the distance traveled by both the aeroplanes in their respective directions. Then we will apply Pythagoras theorem and find out how much distance is between the two planes after 1.5 hours. Okay, let us take the direction mark. Right, so this is north, this is south, this will be east, and this will be west. Okay, so this is the aeroplane, that is airport or aerodrome airport. So an aeroplane flies due north at a speed of 1200 kilometers. So let us imagine the particular aeroplane is at this point after 1.5 hours. Another aeroplane flies in this direction towards west at a speed of 1200 kilometers, speed of 1200 kilometers per hour, and let us imagine that the aeroplane is here at this point. So let us call this point as A, let us call this as point B, and let us call this point as C. So here distance traveled, let us consider this as the first aeroplane and consider this as the second aeroplane. So distance traveled by first aeroplane, distance traveled by first aeroplane is equal to, speed is equal to distance traveled by time taken. So this will be the formula for you. So speed is equal to distance by time. So distance is equal to speed into time. So this is the formula. Let us calculate the distance. So the speed of the first aeroplane is 1000 km per hour into time taken to from here to here is 1.5 hour. So 1.5 hour can be taken as 2 ones are 2 plus 1, 3 by 2 how? 1 into 3 by 2. So that becomes 2 1 times 2 500 times 5 into 3 is 1500 kilometers. So what is the distance traveled by the first aeroplane? It is 1500 kilometers. So this is 1500 kilometers. This is the distance, right? So now we will calculate this distance. So distance traveled by second aeroplane. Distance traveled by second aeroplane is equal to, the speed of the second aeroplane is 1200 km per hour. So it is 1200 into same time, that is 1.5 hour itself. So it can be taken as 3 by 2. So 2 ones are 2, 600 is 1200. So 600 into 3 is 1800 kilometers. So why there is a difference in distance? Because its speed is more and its speed is less. So this is 1800 kilometers. This is the distance. So we have to find out this. So after 1.5 hour, both the aeroplanes are at this point. First aeroplane is at this point, and the second aeroplane is at this point. So this line indicates the distance between the two aeroplanes after traveling for 1.5 hour. So therefore, as this north direction is exactly perpendicular to the west, so therefore we can take it as 90 degrees. So in triangle ABC, we can take, so in triangle ABC, angle C is equal to 90 degrees. So by applying Pythagoras theorem, so here opposite to hypotenuse is, opposite to right angle is hypotenuse. So that is AB square is equal to AC square plus BC square, right? So AB square we have to find out is equal to AC. AC is 1500 whole square, 500 whole square plus BC. BC is 1800 whole square, right? So AB square is equal to, find the square of 1500 and find the square of 1800, add both of them, take square root on both sides, and then find out the distance between the two aeroplanes, right? So from here you will have to carry the problem, right? Okay, so it's a very simple one, but we have to be very careful while converting, while finding out the distance traveled using the speed and time, right? Okay. Okay, we'll go with the third problem, very important. It was asked in one of the examination, some 2 times in the SSLC examination, final examinations. So 2 poles of height 6 meters and 7 meters stand on the ground. Okay, so let us imagine 2 poles. One is 6 meters and 11 meters stand on the ground. If the distance between their foot is 12 meters, so one pole is 6 meters, another pole is 11 meters. So distance between their foot is 12 meters. So this is how we have to imagine. So one is 6 meters. Let us take this as the ground level, right? So another one is 11 meters. So this is 11 meters pole. Okay. and this is 6 meters. 6 meters. Okay. So two poles. Well, let us name this. Let one of the pole be AB. Let another pole be CD. Right. So two poles, 6 meters and 11 meters, stand vertically on the ground. So vertically on the ground in the sense they are 90 degrees with the ground. Okay. So if the distance between their foot is 12 meters. So between the foot distance is 12 meters. We will take this distance here. Find the distance between their tops. So this is the top of one of the pole. This is the top of one of the pole. So you have to find this distance. That is, you have to find distance AC. Right, length of AC we have to find out. Okay, so let AB and CD be the two poles. Let AB and CD be the two poles. Let AB is equal to 6 meters and CD is equal to 11 meters. Okay, now draw a line parallel to draw a line AP parallel to BD. Let it meet CD at point P. Okay, so draw a line from A parallel to BD. Let it meet CD at P. Right. So draw a line from A parallel to the base, that is BD. From A parallel to BD, let it meet CD at P. Okay, so this is the point on P. Now, so here this becomes exactly a rectangle or maybe a square, whatever it is. So maybe it is going to become a rectangle. So this is 6 meters, this is 12 meters. So as this line is drawn parallel to this length will become equal to this. So that is, this PD will be equal to 6 meters now. As this line is drawn parallel to this line, that is, this line is drawn parallel to the base. So as base is 12 meters, then AP will also be equal to 12 meters. So therefore, AB is equal to PD is equal to 6 meters, AB is equal to PD is equal to 6 meters, and then BD is equal to AP is equal to 12 meters. Now comes the very important step. We can now easily find out the length of CP. So here, therefore, CP is equal to CD minus PD. CD minus PD. So CP is equal to CD is 11 meters. So 11 minus PD is 6 meters. So that becomes CP is equal to 5 meters. Right, very simple. So this is 5 meters now. So now, as this line is drawn parallel to this line is perpendicular to this line. So therefore, this line will also be perpendicular to this line, that is AP. So therefore, in triangle ACP, we have two sides and we can easily find out the third side by using Pythagoras theorem. So in triangle APC, angle P is equal to 90 degrees. So by applying Pythagoras theorem, AC square is equal to PC square plus AP square. PC square plus AP square. Okay. So AC square is unknown. So AC square is equal to PC square is 5 square plus AP square is 12 square. So here AC square is equal to 25 plus 144. So AC square is equal to 169. So AC square root is equal to square root of 169. So square and root cancels. So AC is equal to 13 meters. So what is the distance between the tops of both the poles? So AC is 13 meters. We are getting that. So therefore, the distance between the tops find the distance between their tops. It is being asked, therefore distance between their tops is 13 meters. Very important 2 marks question. So it was asked 2 times in the previous examinations. Very important. Okay, let us get into the 5th problem. Very simple 2 marks one. So I have to remember the result of this. It's very important. Find the length of the diagonal of a square of side 12 centimeters. Very simple. Okay, let us get into the solution. So just imagine a square of side 12 centimeters. ABCD is a square. All the 4 sides are equal in this case because it's a square. So and all the angles are equal to 90 degrees. All the 4 angles are equal to 90 degrees. So let us draw this diagonal. Okay. So this is 12 centimeters. This is 12. This is 12 centimeters, and this is also 12 centimeters. Now, so this is a square of side 12 centimeters. Then find the length of its diagonal. Very simple. So ABCD is a square. ABCD is a square. So AB is equal to BC is equal to CD is equal to AD is equal to 12 centimeters. BD is diagonal. BD is diagonal. Okay. Now, very simple. So here, let us take this triangle, that is triangle BCD. In triangle BCD, one of the angle is 90 degrees, therefore it's a right angle triangle because the diagonal in a square divides the square into 2 right angle triangles. So in triangle BCD, angle C is equal to 90 degrees. So by applying Pythagoras theorem, very simple, right? So opposite to right angle is the hypotenuse, that is BD square is equal to BC square plus BC square. Okay, so BD square is unknown, we will have to find it out, is equal to BC square is 12 whole square plus BC square is again 12 whole square. Okay, so BD square is equal to 12 square is 144 plus again 144. So BD square is equal to 2 into 144. So this can be written 144 plus 144 can be written as 2 into 144. So square root of BD square is equal to square root of 2 into 144. Square and root cancels. So BD is equal to 144 is a perfect square, so therefore it is 12 root 2 centimeters. So the length of the diagonal is 12 root 2 centimeters. So therefore length of diagonal is 12 root 2 centimeters. See, this is the answer what we have got because the side is 12 units, so that is 12 centimeters. If the side of a square is A units, for example we will take, so if side of square is A units, then length of diagonal will be A root 2 units. For example, if it is instead of 12 it was A here, instead of 12 it was A, then the length of the diagonal would be A root 2 units. If it was B centimeters, then it will be B root 2 centimeters. If it is 5 centimeter and 5 centimeter, then it is 5 root 2 centimeters. If it is 10 centimeter and 10 centimeter, this would be 10 root 2 centimeters, something like that. So if the side of the square is A units, then the length of the diagonal will be side multiplied by root 2 units. The length of the diagonal is always side multiplied by root 2 units in a square. It applies only for a square, right? So please remember this. This result is very much required in competitive exams or 1 mark questions in your examinations. Okay, we'll get into the 6th problem, very important. So where right angle triangles are connected with arithmetic progressions. So sides of a right angle triangle are in AP. Very nice. I hope you remember arithmetic progressions. So let us take a right angle triangle. So in this right angle triangle, let us take it as ABC, right? So sides of a right angle triangle are in AP. So when the sides in the sense, how many sides are there? There are 3 sides. So how to guess 3 unknowns in AP? So it's a pattern, we know that. So it is A minus D, A and A plus D. That is the method we are going to guess. So usually A plus D will be the longest side because it is the hypotenuse. Another one is A minus D here and A will be here. So A minus D and A plus D. So let the 3 sides of the triangle be that is A minus D, A and A plus D. So sides of a right angle triangle are in AP. So we'll guess the angles. So let the 3 angles be A minus D, A and A plus D. Right. So now show that the sides are in the ratio 3:4:5. So that is, as we have guessed this A minus D, A plus D. So we have to show that the sides are in the ratio 3:4:5. So in that manner. Okay. So in triangle ABC, it's very simple. So angle B is equal to 90 degrees. So by applying Pythagoras theorem, so AC square is equal to AB square plus BC square. AB square plus BC square. So AC is A plus D, so therefore we can write A plus D whole square is equal to AB is A square, A whole square plus BC is A minus D whole square. Alright, so A plus D whole square can be written as A square plus D square plus 2AD is equal to A square. It can be written in the same manner. A minus D whole square is A square plus D square minus 2AD. Okay, so here A square and A square cancels, D square and D square cancels. So plus 2AD, here we have minus 2AD, it cannot be cancelled. If they are of the same sign, they can only be cancelled. So left over thing is 2AD is equal to A square minus 2AD. So we'll transpose this minus 2AD to LHS because they look like like terms. So 2AD plus 2AD is equal to A square. So therefore A square is equal to 4AD. A square is equal to 4AD. So this can be written as A into A is equal to 4AD. A and 1A gets cancelled. So we are left over with A is equal to 4D. The value of A is 4D. So that's very simple. A is equal to 4D. So now we will move on to the next step. So here, let us get into the first side, that is AC. So let us get into this BC. So BC is equal to A minus D. So this can be written as A is 4D minus this D. That stands to 3D. Another one is AB. So AB is equal to A. So A is nothing but we have got the value, that is 4D, and AC is A plus D. So that is A plus D is equal to A is 4D plus this D. So that becomes 5D. So therefore BC is to AB is to AC. Can be written as BC is 3D and AB is 4D and AC is 5D. So D and D gets cancelled. So remaining thing is 3:4:5. The sides are in the ratio 3:4:5. So this is the connection between the Pythagoras theorem and arithmetic progressions, right? So in this session we will conclude with these problems. Please write it down in your classwork very neatly. So coming Sunday morning at 8 o'clock you are having a test on the problems related to Pythagoras theorem. So practice the problems well. So in tomorrow's session I will be going with still more very important riders, very important riders on Pythagoras theorem, right? So until that, stay home, stay safe and keep learning. Thank you.